my name is Carly Franklin, and this is my submission for Physics 2, Lab 1, covering the charge tape experiment. As an introduction, the goal of this lab is to find out whether there is an excess charge on pieces of tape by measuring the distance between the two tapes that are temporarily charged. And by using Newton's third law, Coulomb's law, and the gravitational force equation, we can determine what the charge of the tape is. And the charge of the tape was ultimately determined to be 1.25 times 10 to the negative 8 coulombs. And to the right, you can see an image of the experiment setup, and the tape on top is gradually being lowered until the bottom tape, quote unquote, floats up, and they're attracted to each other due to their opposing charges. And then at the top of the screen, you can see the relevant equations. The gravitational force equation for the gravitational force that is acting on the bottom tape, and then Coulomb's law, which explains why the charges will be attracted to each other. And more on that later. The experiment is modeled as shown. The length of tape is going to be 0.021 meters. That's what we measured. And then the system will be the tape resting on the books, the source being the tape being held to the tape resting, and everything else around it. And then the distance between the tapes, once the bottom tape began to float, it was 0.012 meters. And then the two pieces of tape were brought together. And to the right, you can see the calculations that we used for the force of gravity and then the mass of the tape. And Coulomb's law predicts that there will be an attractive electric force between the two tapes, and they will attract to each other due to their net attractive force. This is the glow script code, which we use to model the experiment. The initial conditions are shown on the left, where I input the mass, length, width, distance, and an important assumption that we made that will be discussed later is that the tape pieces are simplified to be treated as point charges, which makes our calculations much simpler. And secondly, our calculations are determining the force of gravity on the tape, because that will also determine the electric force on the tape because of Coulomb's law and Newton's law that opposing charges are equal and opposite. Time for our discussion. The magnitude of the charge, as shown in the introduction and in our model, was 1.25 e to the negative 8 coulombs. The assumptions we made, air resistance was determined to be negligible, and then it was also not really moving, so the air resistance wasn't too big of a factor. The tape was treated as a point charge, which is not realistic because it is long and wide, and point charges are extremely small and not imperceptible. And then we assumed that both pieces of tape had equal charge with uniformly distributed charge. If the electrons were positive and the protons were negative, so like a flip scenario, it would be treated as negatively charged tape, and the directions of the electric forces would be opposite, flipping the motion that we observed, but they would still be attracted to each other, and Coulomb's law would be the same, the magnitudes would remain the same. The only thing is, it's just flipping the charges, which they're still attracted to each other. And it is important to handle the charge tape as little as possible, because contact with the electric fields, electric forces, it could cause the tape to lose electrons and become more neutrally charged. And then, as shown in the images in the beginning of the slideshow, they would no longer be attracted to each other. Possible errors with this experiment, possible error measuring the lengths of the tape, and possible loss of charge due to excessive contact, but I don't think that error is as applicable because our tapes were very, very charged and snapped together quite quickly when they were brought into proximity. And then lastly, the experiment and the glow script code show that the tape had a positive charge. And Coulomb's law describes how the electric charges between the two charged tapes depends on the amount of charge that they hold and their separation. And depending on the gravitational force, the electric force will just be opposing that in the opposite direction due to that Newton's law. And that's what we discovered in this equation, or in this experiment. Thank you so much for listening.